disk task equals 72 bar. हो रहा है, वहां से सीधा सीधा हो रहा है फिर भी है। अब समझ गया, आउटपुट 4 क्या आ रहा है, राइट वाला भेज दिया ना उसने। ठीक है, शुक्रिया। तू तेरा बाप हट। Only one test case. that. I think it's the audio.わかったぜ。わかったね。わかるやろ。なんだよ。まみ。なんでだよ。अभी ये क्या हो गया? हाँ अभी तक तो आ रहा था, सही आ रहा था ना अभी तक तो। हाँ यार पता नहीं क्या ही है। Fuck is this? No. My phone is here. पहले में बात नहीं हो जाना चाहिए था क्या? यहाँ पर हो रहा है ना सीधा सीधा। मैंने यहाँ पर 4 है मेरा, इससे छोटा है। यस इससे मेरा केस 4 है, 4 इससे बड़ा है। Should happen. What's wrong with it? Am I making some mistake? It could be a typo. Nah. again at the bomb. कान में देखो, कान में ये कान मार लो ना। सीधे सीधे बोल रहे हैं यार। मैंने समझ नहीं आया इसका नहीं निकाल चला तुम्हारे बाप ने भी कहा था क्या है, तुम्हारे बाप ने भी करा था क्या? बकलोड़ी कर रहा है माँ साथ। ये गलत है, वो गलत है। नान दायो, नान दायो। हट रहा मैंने नहीं करना भाई। इसको क्या है, ये क्या है अभी? तेरी माँ का I'm a Barbie girl, you're my Barbie girl. मैंने करना ही नहीं है, मैं समझ लिया ना। मैं तो समझ गई, मैं तो कर लिया यार। एक के चक्कर में तो बिना कर दूंगा सब कुछ। हाँ मैं तो परेशान हो चुका हूँ, देख लो अभी। मैं तो हो चुका हूँ परेशान, है ना। मेरा हो गया है काम खत्म, मैंने करना ही नहीं ना। I'm a Barbie girl, you're my Barbie girl, you're my Barbie girl. I'm a Barbie girl, you're my Barbie करने नहीं है। I'm fucking wasting my time. Fucking wasting my time. What's wrong with you now? What's wrong with you now? With you? भाई ये खुद बोलना भाई यार मत सा only one test please. Because of this, I'm losing my mind. I don't even know what was I writing. I have no idea. Mommy. It's a fuck. Fuck you. Fucking air. Fuck you. Fuck you. Hi, Sparky. Okay. You see that? You see that? Only one test keys. Only one. No, why? Binary sort. Yeah, it's binary sort. That's my first algorithm that I've learned. I'm tired. Bro, I wasted 1.5 hours trying to figure this out. Yesterday I did 3 questions and today I can't even do 1. What the hell is this? I've had enough, man. It's enough for me. Nummate should be there at 21. Nummate length -1 instead of num0. What? At 21 length -1. At 21, I don't get it. Nums met. So should I just remove all this, or just here? Okay. I'm gonna send the code to you on Discord. Like, make the change and please send it back. I'm not getting it. What you're trying to say? Actually, logic is a bit overcomplicated. You can do this easily in less code. Yeah. Instead of that. Yeah, it's more complicated, but I sent you the code. Like, please, uh, make it nice. What? Oh my lord! I know it looks shit. I know. I tried. I'm just trying to make it work. When it works, like when I get the right answer, after that, then I try to think about like how can I reduce the code, make it more good. I sent it. Like, did you receive it? Maybe. Are you? Let me copy paste my own lead code from 2021. Oh, really? Should be that. No, I'm sure. You see? What? You seeing this? Only this? Only this? How can this work? Huh? That's wrong. Maybe here you are seeing. I should change it. That me. I mean, it's the HK. Amma. So. Okay. Let me. My code is shit. It's a shit boy. Okay, okay, like that and like that. Okay. Okay, running lat mid is that. What? What kind of code is this? So simple. If number mid is okay, if mid is greater than +1. I thought then if mid right one is bigger than left shifts. Okay, we go to the right. Left is gonna shift. Else the right is gonna shift to mid. Mid. Actually, right, can we do like that? Okay, let's see if it, yeah. ちょっとね、ちょっと待って。I think my code can also work. If you are right, then Evra. Right. What's wrong with my light? Okay. My right. How about this one? How about this? Please. Okay, it's right. My code is shared. Yeah, that's. Ma, why couldn't I think like this? What should I do? Like submit it? It's not my code, but check this video out. It explains well. You understand code logic behind. So it helps in future problems to understand code. Okay. Okay. Mane. Oh my lord. I'm gonna submit this one. Okay, I'm not seeing your comments, sorry for that. Instead, actually a bit do you want a good video to understand? And similar problems will be easier after that. Watch a video I said I can't get it. Beats 100% other codes. It's crazy, Lama. How people have these too. I've had enough. I'm not doing it today. I've had enough of lead code for today. Actually, let me show you how many problems I've solved. It's going to be here, I guess. Shouldn't that make it? Oh, that should make it 4. Means 8. 1, 2, 3, 4, 5, 6, 7. Only 7. What? Okay, my. Yo, yesterday I solved. What do you mean? Okay, it's not a mid. It should be a mid. Perfect. Who cares? Mid or not. Watch the video if you want. That will give you perspective of solving problems. It's good to have that mindset. Okay, I will. My problem solving mindset alone helps you solve majority of questions. I mean, should I walk? I think I can. Is it okay to watch that video here? I can, I guess. I think it's very noisy here. Let's watch it together. Okay. Might try not to watch videos. Like I don't like watching videos. But to be honest. Okay. What they add? How'd I go? Okay.
Welcome back, and let's write some. Hey everyone, welcome back, and let's.
Well, in coding, if you don't understand a concept, it's better to watch a video and do it again after learning.
Write some more neat code today. So today let's solve the problem, find peak element. We're given an array of integers and they don't mention it here. It's mentioned all the way at the bottom of the description, but it's a very important fact, and it is that any two adjacent elements, suppose a number at index I and a number at index I plus 1, these are never going to be equal. So any adjacent elements in the array, important fact, and it is that any two adjacent elements, suppose a number at index I and a number at index I plus 1, these are never going to be equal. So any adjacent elements in the array are not going to be equal. That's a very important fact for this problem, so I wanted to mention it at the beginning. We want to find a peak element within this array. A peak element is kind of how it sounds. So imagine that there are three elements. The peak element is the one that is greater than both of its adjacent neighbors. Now, it's possible that there could be multiple peak elements. That's okay. We can return any of them. So we could return this one or this one. Now, what if our array looks something like this? 3, 2, 1. At first glance, there aren't any peak elements in this array. But the way they define peak elements, these endpoint values, suppose 3, it's greater than its right neighbor, but it doesn't have a left neighbor. So can this be a peak element? Well, the answer is yes. Any endpoint value like 3 is implicitly assumed to be greater than its neighbor if its neighbor doesn't exist. So if its left neighbor doesn't exist, 3 is considered to be greater than its left neighbor. For 1, since its right neighbor doesn't exist, it's assumed to be greater than its right neighbor. Now, it's not greater than its left neighbor, so this is not a peak element, but 3 is a peak element. It's greater than this, and it's greater than this. Given those facts, we are guaranteed that there's going to be a peak element in this array. Our goal is to find it. It'd be pretty easy to do with a linear scan, but they actually want us to do better. We want to do this in log n time. Are there any algorithms you can think of that are log n time? Well, pretty much the only one that would work in this case is binary search. But is it even possible to run binary search on this problem? Well, let's go back to basics and think about what binary search is as an algorithm. We have an array, suppose 1, 2, 3, 1. Usually we have a left and right pointer. We calculate the midway point. Let's say this is the midway point. We have a pointer here. We check, is this guy a peak element? Check its left neighbor. Well, it's greater than its left neighbor. Check its right neighbor. It's not greater than its right neighbor. So we know for sure this is not a peak element. But the idea behind binary search is that we should be able to eliminate half of the search space every single time. We should be able to either say, okay, we know for sure there's no solution on this side, so we're going to search on this side. Or we should be able to say the opposite. We know for sure there's no solution here. Let's search over here. But we can't really say that with this problem. There could be a solution here or here. And it's actually possible there...
I thought the same. But then I wrote that shitty code.
could be a solution on both sides of the array. So let me say this slowly. This is going to be a modified binary search where we don't necessarily have to be up sides of the array. So let me say this slowly. This is going to be a modified binary search where we don't necessarily have to eliminate half of the search space every single time. We're just looking for a single peak element. So we just have to be sure that the side that we decide to search on, whether it's this side or this side, we have to be sure that the side does have a peak element. Maybe there's a peak element on both sides, doesn't matter. We just have to be sure that there is one on the side that we're searching. If this is not a peak element, how do we know which side is guaranteed to have a peak element? Well, let me show you a very simple example. Let's suppose that our array was monotonically increasing. So these points kind of represent the values of our array. Is this a peak element? No. Is this a peak element? No. Is this one? No. Is this one? Yes, it is, because it's greater than its left neighbor and it doesn't have a right neighbor. So this is a peak element. So if we were running our binary search on this array and we looked at this point and we saw that this value is not a peak element, so we're not going to search here. Which side do we want to search, on the left side or the right side? We're going to go on the right side, because even though we can't see the entire array, we see that its right neighbor is greater than it. So maybe this is a peak element. Maybe this point doesn't exist and the value is actually somewhere down here. So we know this is not a peak element, but this is greater than its left neighbor and it's also greater than its right neighbor. That's a possibility. But even if it's not true, even if this value doesn't exist and it's actually all the way up here, look, it's still guaranteed that there's a peak element because all the way at the right. Either this is going to be monotonically increasing, which guarantees that there's going to be a peak element on this side of the array, or it's not monotonically increasing, which means one of these points, suppose this one is going to be down here, or maybe, there's a few more points, and one of those is going to be below. So like this one would be all the way down here. And in that case, it's also guaranteed that this is a peak element as well as this being a peak element. Can you kind of see the intuition now? Either this portion of the array is monotonically increasing, which guarantees a peak element, or it's not monotonically increasing, which means that there's going to be a dip somewhere, which also guarantees that there's a peak element. And that's true because we know for sure that this is not a peak element, but its neighbor is greater than it. So it's already increasing here, and it might keep increasing or it might dip somewhere. Now, the opposite could have been true as well. It could have been going downwards. It could have been monotonically decreasing. So if we looked at this value and saw it's not a peak element, which side are we going to decide to search on? This side, because its left neighbor is greater, so we're guaranteed that there's going to be a peak element here because it's monotonically decreasing, which means all the way at the left is going to be a peak element, or there's going to be a dip somewhere, maybe here or maybe here, which guarantees that there's going to be a peak element. So if we are running binary search and our mid value, suppose in this case over here, is not a peak element, we're going to search on the side that has a neighbor value that's greater. And we're guaranteed to have a neighbor value that's greater, because if we didn't, if this was like 1, for example, and this is 2, and this is 1, then by definition, this is a peak element. So if this value is not a peak element, we're guaranteed that one of its neighbors are going to be greater than it, and that's the side that we're going to search on. It's really that simple. I know it's probably not simple to come up with, but once you understand it, it does make a lot of sense. So now, wrapping our binary search up, we're going to take our left pointer and shift it to be mid +1, so it's going to be over here now, and then we're going to recalculate the mid pointer to be left plus right divided by 2, which I think is going to be over here. So then we're going to check, is this the peak element? We're going to compare it to its left neighbor, it's greater. We're going to compare it to its right neighbor, it's also greater. So this is the solution. We return the index in this case, I believe. Yep, over here. And since this is binary search, it's running in log n time, constant memory. So now let's code it up. So this is mostly going to be a cookie cutter binary search. We're going to initialize our left pointer to be 0, our right pointer to be all the way at the end, length -1. And then we're going to have our while loop. While our left pointer is less than or equal to right, we know for sure that we're going to return within this loop, so we don't really need to put like a return statement out here, so I'm not going to bother with that. But we're going to calculate the midway point. We could say left plus right divided by 2, but it's possible that that overflows. A way to make sure that it never overflows is to do it like this. Basically, take the distance between right and left, which is right minus left, divide that by 2, and then add that to the left pointer. This is basically another way to calculate the midway point that just guarantees that it's not going to overflow. Most of the time, you won't need to do this in coding interviews, but I think it's helpful to know how to do it. Now we're going to check, is the left neighbor greater than the value at index m? How do we check that? Well, basically check the value at index m is less than its left neighbor at m-1. If that was true, we would say we're going to search on the left side. So we say our right pointer is going to be mid minus 1. Now there's one catch here. There's one edge case. What if m is equal to 0? In that case, is it greater than its left neighbor? No. So we are going to check that m is greater than 0. It's not equal to 0. It's greater than 0. And this is true. That also helps us because then we will never get an index out of bounds error here. And we can do the same thing to check if its right neighbor is greater. So I'm going to copy and paste the above and just change it up a bit. Instead of checking if m is greater than 0, we're going to check if m is less than the rightmost position of the array, which is length of nums minus 1, and the value right of it, which is not m minus 1, it's m plus 1, is greater than it. So if this is true, if its right neighbor is greater, that means we're going to search on the right side. So we're going to say left is equal to m plus 1. So we have the two cases where we're either going to search on the left side or on the right side. But if we don't do either of these, that means we for sure found the solution. So else is the case where we found the peak element and we want to return the index, which is m. So that's the entire code. Now let's run it to make sure that it works. And as you can see, yes, it does, and it's pretty efficient. If this was helpful.
You are simple. You either go one side, either left or right, just to find that peak point. We just need only one. What's simple, man? And now code it again from scratch. Ah, really? To solidify this knowledge. Okay. Let's solidify. Wow. Okay, I don't know. Peak. We're gonna solidify. What should I do with this? Okay, I'm gonna remove it. Okay. Okay. We can have a left. We're gonna have a left, which is going to be 0, and our right is going to be nums dot layout. That's how it works. Questions you don't know, if you learn concept and do it yourself. Alright, do this while I do my Yankee. Okay, sir. We're gonna while a loop until left is lefty, left is righty. I was almost there, man. Was almost there. I'm sad about that. I was almost there. Not there. Okay. Now we gotta find a mid. Nandaka Kandaka. I like to have it outside. Okay. Yeah, I have a very bad habit of control and enter. Yeah, come on. I know. I didn't submit the answer. It's similar to Anki. You don't know beginning, but once you learn many problems, other problems become easier, as you already know. Similar Kaji. I saw that, like, I've been for 3 days I've been only doing binary search and I've solved 7 problems. I mean, yeah, like 5 problems on binary search. This was the this is the one I could have solved. Oh yeah, this was a better. What am I doing? Lapildura. Right, am I writing it right? Do I even need that? I don't need that. Why do I need a mid? Bitch, what am I doing? Sorry. Learning binary search is good. It's like first of the most important core concept. Yeah, I've been following a book and like binary was the first one, so I just went with binary. I mean, that's why I'm like, I read about binary, how it works, and then started solving problems, and now after like 2-3 more problems I'm gonna go back to that book and then more course. Okay, I'm gonna look at nums. Okay, nums my mid. Oh, I still need a mid. I think I need a mid. Right plus left. Yeah, you need my mid. Okay, if my mid is if I'm going right, that's for sure. Like I can go either this side or that side. So yeah, either we are going this side or that side. So if my mid is smaller, no, if it's greater than my nums mid, okay, this is my mid, that's my mid. If I'm smaller than my right, okay, we do it like that. If I'm smaller than right, oh yeah, nums. If I mid plus but I use my hands. Then no, not return yet. We just gonna, my left is gonna shift to my mid plus 1. Please with the please work, else is like it's the pause. We're gonna keep doing that. Boom 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 boom. Okay, and else it's like it's the opposite, so we don't have to write anything. It's right equals mid minus 1. Then we can just return mid. That's it's maybe it's wrong. But we'll just try it. We'll try it. Wow. ありがとうございます。Okay, なんだこれ? Output is 4, expected is 5. 0, 1, 2, 3, 4. And then 5. Uh, uh, okay, again, I'm struggling. Okay, I got it. This is I'm here. Okay, I cannot do it like that. Okay, I need a paper and pencil. I'll do it. Unknown. To debug, try to run the program without submit. Like I'm deleted. What is going on? See what mid was, how it went. Can you console log it? Like upgrade to premium to use a debugger. Nah, debugger. Actually, I can use my this. Man, I can use my VS Code, I guess. You can't console log in interview. Isn't it okay? In your actual job, you always do that. You gotta learn to debug on paper. Okay, yeah, I mean, that's what I'm doing. I have a, actually you cannot see, but that's what I'm doing. I like, you said to debug, so I thought like you could do that on screen. Do you want me to explain it? I can hop in a car if you want an explain. I can hop in a car and yeah, of course. You need to debug it on paper, not by console log. Yeah, that's what I do. I have this. Wait a minute. I like, give me 2 minutes. I can do a call. I'll be back. I need to use toilet. Be back. Wait just a sec. I got it. Ma. I'm just not doing it right. Like, I do not want to copy his whole code. That's why I'm trying to write a different code, which does the same thing. Share screen. Toira. Hi, I'm Toira. Be back. Copy. I